All right. Let's see if this works. Hi, everybody. It's been, I don't even know. I have no idea how long it's been, but a long time since last we chatted. And I'm pretty excited to be back. I think, frankly, the last thing we talked about was the last new Raspberry Pi 3, which kind of tells you just how long ago this was. Anyway, I'm back because I think I've come up with a new format that's going to make it a little easier to do these things. And the idea is each week I'm going to try to show off one thing. I'm not going to spend like an hour talking about 25 different things. I'm just going to go over whatever seems interesting that week. So this week, I had been I hate to admit this, but I've been kind of terrible at GitHub for a really long time. I'm not a developer, so I haven't really needed to know how most of GitHub works. I just kind of cover the things that I deal with, and that was it. So over the past couple days, I've been doing some research and learning how GitHub actually works, and so I thought, you know what, it might be cool to show exactly what everybody in the team does to all of the users out there. So with that in mind, let me pop this up. All right, so here we are. This is sort of the main GitHub page. This is what you see when you first log in to GitHub and you go to Kodi's repository. Thanks to the whole history situation, the actual address for this is github.com/xbmc/xbmc. History being history. And if you first look at this page, it can be pretty overwhelming, I think, without question. There's like 10,000 things on the screen, and every one of them is, it seems like it comes in the thousands. So sort of the first goal of this walkthrough is to kind of explain this first main screen. And maybe talk a little bit about exactly what GitHub is and what GitHub does. First off, I guess the very first thing that you can do when you're thinking of GitHub is think of it as essentially just a place where you stick a bunch of folders with text files in them and maybe some pictures. That's really it. GitHub is it's a repository that holds folders with files in them that have code written inside those folders. And if you look here, this is the main master branch of Kodi. You'll see that's exactly what this is. It's just a library directory showing you all of the files that are inside of Kodi. Literally all of them. All of them are in these folders and in these files, including, for example, this README here, which is shown right here. And it kind of talks about Kodi, talks about how to install it, some useful quick development links and other links, and so on and so forth. So we start with that basic understanding. GitHub, a GitHub homepage like this is just where you store all of your files and folders. And by the way, I should say I'm monitoring YouTube chat right now. So if you guys who are watching want to ask questions or interrupt me or whatever, feel free. At the moment, all I have is a test word up there. So yeah, feel free to comment if you want to. So with that said, let's talk about why this is so useful and so important for everyday development of Kodi. What happens is, once you start with this master branch, every developer then pulls that master branch into their own into their own computer or personal directory or whatever, by one simple method. They go up to this corner right here, and they hit this button that says fork. And that creates their own directory of all of these files and folders, which they can then do whatever they want with. Do all kinds of crazy things to. They could delete them all. They could add tons of other folders and files. It doesn't matter. They can do literally whatever they want to that. to their own folder. And so to show you what that looks like, first, we'll just hit this button. And we'll fork it to my own directory. And there we go. Now it's forking. That sounded bad. That sounded pretty bad. This should only take a few seconds. Okay, so while that's going on, let's go back. Oh, and it's done. So there we go. Now we have, this says up here, forked from xbmc/xbmc into my own personal directory, Nate Thomas at xbmc /xbmc. And now it's totally clean. I haven't done anything. There are no pull requests coming to me, and I'll explain what those are in a second. There's pretty much nothing. No projects. If we click Insights, nothing's happened because this is all my own fork of the main system. So let's go back to that system. And before we kind of get into what I can do with my fork, let's take a look and see what we can just see from this web page. Most importantly, we can see two really big things. This right here, pull requests, and this right here, insights. Insights is not necessarily that helpful in terms of day-to-day operations, but it gives you an idea sort of what's been going on with this software for who knows however long. And in particular, this is really, if you want to see just the history of Kodi boiled down, you can click contributors right here. And it's crunching the data. It says hang tight. And there it is. This is all of Kodi from the moment we first started kind of keeping track of everything. This starts September 20th, 2009, well before we even flipped over to GitHub. You can kind of get an idea of when we flipped over to GitHub. There's a moment when the tracking really starts going off the rails. I don't know if you can see that. It's pretty obvious. And from that point forward, you can see all of the stuff that's been going on with GitHub. And what this is, it says right here, contributions to master excluding merge commits. In other words, these are just commits to master. I think I should go back and explain what commits are, and I will do that in a moment. But for now, let's just kind of go through and look at the cool history of Kodi and XBMC. As you can see, the number of commits that happen over a period of time kind of vary pretty wildly. Sometimes there are tons, sometimes there are little. And usually the reason why there are big spikes... Oops. Oh, somebody wants to play a game. Usually the reason there are big spikes is because somebody's committed something really big, or we're getting close to a release, or maybe we're getting close to release and there are way fewer commits because right now we're only doing bug hunting and that kind of thing. You can also see down here the people who have done the most commits over that period of time. And if you spend very much time in GitHub, you should recognize basically every one of these names. Monaleza, who did an incredible amount of refactoring for settings and all kinds of other things. Fernet Menta, who is involved in audio player and video player and does, once again, an incredible amount of refactoring. Memphis, who I want to say he handles mostly Mac stuff, but that's not really true. He does an incredible amount. DeVille is another guy, Queso, M. Kortsteiger, and the list goes on. All of these guys over the course of their history, and you can even see their history where they did most of their committing. All of these guys are the unsung heroes of Kodi, the guys who have done more development for this work than I can even imagine. They have sunk so much time into this. It's just for a moment worth appreciating what they've done. So with that said, let's go back to the code. And let's go to this thing that says 48,000 commits. So let me boil down what a commit is. A commit means after, you remember we forked the software. After you've forked the software, you then can do all kinds of different things to it. But let's say for a second, all you want to do, and you know what? Here, let's do this. Okay, so here is my forked version of Kodi. Let's say all you want to do, you found some minor problem in the README, right? So here's this README text. Let's say you click the README, and then this is not normally how it's done, but for the sake of this discussion, let's say you click edit this file. And you say Kodi is an award-winning free and open source GPL. And let's say we wanted to change it to GPL 2.0 or 2.0 plus. Then you go down, well, let's see here. You go down and you click, and you probably want to explain everything that you're doing, but then you click commit changes. And that's it. That's a commit. You have committed a change to your repository of software. I'm going to cancel because I don't want to commit that change. You know what? Never mind. I won't click cancel. Let's commit this change because who cares? This is my own branch. I can do whatever I want. So here it is. Now it says GPL 2.0, the greatest. And what if now I'm so proud of this. I'm so pumped about what I've done that I want to update this to the main XBMC master. What I can do, I'll go back so you can see what I did. Once again, we're back on this main page. Now I want to say, hey, master branch, XBMC/XBMC, king of all kings, I want to make this change public for the world. So I click new pull request. And GitHub, being smart like it is, compares the base master fork with my fork and checks out to see what's different. And it says, I see you want to remove this old line and add this new line. And that is how you commit a change. So now I can create a pull request. And when I do that, it'll show up. And I'll show you what it looks like on the other side on the main master branch XP in a second. But it'll show up in XBMC, and then everyone can comment on it and say whether they like it or not, whether they think it's a good idea or not, and so on and so forth. I'm not going to do that now because this is a bad idea and we don't want this merged. But we could merge it if it were a good idea. So let's back up. So there we go. So there we have my sweet own history that can be merged without any problem right away. And now let's say that my great change got merged. What do I do now with this fork of XBMC? Because it's not very useful anymore. And here's the dirty problem with forks. The fork stops changing the second you do the forking. That sounds so horrible. But it's true. The fork stops changing. So all of the new commits that happen after this one that happened 10 hours ago, you will not see in your own fork. And so there's a very good chance your fork will age and get less and less useful as time goes on. There are ways to fix that, but I'm not going to get into that now. So the simple thing to do, once our PR, and that's what we call them, pull requests we call PRs. Once your PR has been merged, and you're done with this fork, you can do the simple step of, oh wait, let's see here. Oh wait, I hit the wrong button. You can go to settings, and you can go all the way down to the danger zone, and then you can delete this repository. I know, and it sounds scary, and they're going to make it seem scary, but I'm going to do it anyway. This action cannot be undone. It will permanently delete. Please type in the name of the repository to confirm. So I'm going to do it. Nate Thomas /XBMC. I understand the consequences. Delete this repository. And there we go. The repository is gone. So let's go back to XBMC. So now we've created our pull request. And for the developers out there, this should be the way once you created your fork, What you need to do next really is more of a developer question. What you're usually going to do is take your forked copy of XBMC, download it to your computer, whatever kind of computer you have, and then work on it there. Then you can compile at home, do all the things you need to at home, make sure it actually works before you submit your pull request. And then once you've done everything you need to do at home, you can then re-upload it back to your fork and then make a pull request, which is the right way to do it. Most people are not going to do the simple thing of create a fork, what I just did, create a fork and then edit directly inside GitHub, because there's no way to test from inside GitHub like that without a whole rigmarole. And we don't, it's just a lot easier to do it from your own home. Oh, and we have our first comment. Hey, Milton, nice to meet, nice to see you on here. If you have any questions, feel free to ask them. So there we go. So we've created our pull request, and now we have to go through the gauntlet. That's right. Every single pull request that gets submitted to XBMC goes through. We don't call it the gauntlet, but it's essentially a gauntlet. We have to. I'm going to dismiss this. We have to submit it here. We have to make sure that it fits all of our requirements for what makes a good PR. And then once we've done all of those things, people will either decide to accept it or not. So, for example, let's go to this Kill Global C Stereoscopic Manager. And I can go into this. I'll go into why we're making this particular PR. There's a lot of Kodi that depends on other pieces of Kodi. And if those other pieces are broken, then that breaks yet more pieces, and it becomes this cascading waterfall of everything breaking because everything depends on everything else. And so there's this desire to fix that. The reason this happens is because we have something called globals. And so if you kill a global, that means you get rid of at least some set of dependencies. So here, one of our developers named Garbear, whose real name is Garrett, and who works mostly on RetroPlayer, if you're familiar with that, has submitted a PR to kill this particular global. And by doing so, he's gone through this sort of checklist. He gives an explanation for what it does, talks about other PRs that it interacts with, says how he's tested it locally, and that's an important thing in Kodi development. If you want to submit a PR, you have to test it somewhere or other. Except for maybe document changes, like changing the README, but that's sort of the exception, not the rule. You really do need to test it at home before going forward. And then you have to say what kind of change you've done. So he has done an improvement. It's not a bug fix because there's no bug. Nothing's necessarily broken. And it's not a new feature because the end user isn't going to see anything. And it's not fixing a break. All it does is improve the code base in some way. So he's selected that. And then, as you can see, he's also gone to the reviewers and assigned or asked two reviewers, Fernet Menta and Dave T. Blake, to take a look at this PR and let us know what they think. So Dave takes a look and he gives his info. Fernet does his review, and he reviews inside each individual file, and you can actually see. So here's the commit, and I'm going to open it up. And this commit actually applies to multiple different files, which is something you can do when you're editing at home. But it affects application CCP, GUI info manager CCP, video player CCP, and so on and so forth. Ultimately, there are 14 files changed in this whole, in just this one pull request. And so everybody kind of goes through and lets them know what they think, whether something needs fixing in some way. With globals in particular, because they're so likely to interact with other pieces of Kodi, a lot of times what will end up happening is a person will open a PR for one global and discover, through trial and error and testing, that just that one global, changing it and fixing it, results in breaking 3 other globals. And it results in 10 globals all getting fixed all at once. So he's submitted this. There are reviewers. Everything's been reviewed. Here are some labels that have been added, and a milestone. We want to get this in before Alpha 2 for this upcoming Leia 18.0 release. And so it's an open PR. I can't really say what's going to happen to it because I'm not one of the reviewers, and I would never even dream of being one. But once it's all gone through the review, you can see here we have 141 open pull requests like this. Once it's gone through review, it is either merged and closed or not merged and closed. But either way, it's closed, which is why over the course of our history, we now have 13,242 closed PRs. It's also the reason why I didn't submit a PR for that change to the README. I don't want my name to be on one of the closed PRs that everyone rejected. I mean, it's fine to have a rejected closed PR, but not for something as stupid as changing the README wrong. And so we have all of these lovely closed PRs. And each of these PRs, the title is supposed to be descriptive enough, and it's true for open PRs too. The title is supposed to be descriptive enough so that you can kind of get an idea what's going on pretty much just by eyeballing it. Where did it go? So that one by Garbear, you can see Garbear made it. The title explains what it is, and it's an improvement, and hopefully it's for V18. But there are others. Let's see, clean up. One's exclusively for Linux here. One's exclusively for the GUI engine rather than the overarching Kodi engine. There are thousands of these. There are not thousands, but there are quite a lot of these tags that you can add to each of your PRs, including this one. This tag is called Work in Progress, and it's a little bit of a different tag. No, it's not really. It's a different tag because what it is saying, I don't intend for this PR to get merged. The reason exists is for everyone to see one possible way to do whatever it is we're thinking of doing. And you know what? Maybe we won't even do it in the first place. It's just kind of an idea. So this was a work in progress idea for how to get rid of dummy add-ons, or a work in progress idea of how to finally create a binary repo that lets us take all of those things like PVR add-ons and pull them out of Kodi so people can download only one or two or whatever they need. Anyway, each of these tags is separate and different and does what it does. Here's one for games. The reason, though, I highlight this work in progress tag is because GitHub and GitLabs, like I said, I've been doing some reading. They handle that particular tag slightly differently. GitLabs goes to kind of goes through the process of asking you if something's a work in progress earlier in your PR submission. It's not just its own tag. It's like the first tag that you get asked whether this is a real PR or not. So that's open PRs, closed PRs. Let's see. What other things can we look at? We can check out milestones. Yeah, let's do that. So here are the milestones. Here is every closed milestone. These are all of the points at which we're working towards finishing with the code, and branching is what it's called, where we have our main code base, we pull the code out. It's basically a fork, but I think don't quote me on this one. We branch out the main code base into this separate fork, and people can still work on it. But it ultimately results in Krypton 17.1 and 17.2 and 17.3. The milestone just means this is our goal. So there hasn't been a fork yet, but our eventual goal is this point. And all of these PRs are intended for this point. And once all of those PRs have been closed, and that's why it's closed, it says 0 open, everything closed. Then you can branch, and you can not necessarily release, because we're going to have to go through the bug process and go through it all over again to fix all the bugs, but you're a step closer to releasing. That's the point at which we get to our alpha releases and our beta releases and our release candidates. The open milestones, these are what's left, are open milestones for, potentially a new Krypton 17. I don't think we're going to put out another Krypton, but in case somebody thought it would be a good idea, that milestone exists. There are abandoned and obsolete or superseded milestones, and the milestones for the upcoming Alpha 2. Which, as you can see, there are 7 open right now, including, well, we can just see what those are. It includes that stereoscopic manager, the GUI refactor, and a couple other different things. These are, since we're in alpha stage, we're still able to add some kind of major changes, but for the most part, these are all sort of things will get done pretty soon. That's sort of the general thinking when we tag a milestone for something pretty close to upcoming. So those are PRs. Let's head back. Those are milestones. I've already kind of talked through labels, but we have 60 of them, and I'm not going to go through them all, but you can look through them. They're all basically self-explanatory. And if you consider yourself a specialist in one area, this is one nice way to just look at the open PRs. So let's say you are, what's something that's got a lot of PRs? No, that's not. Let's say you're an input guy. You click input and you see all of the PRs that have been tagged input. So it's a nice, useful way of checking out just the things you're interested in. Finally, I should go back and mention one more thing with the pull request. So if you are familiar with how software development works, especially modern software development, you know that there's this sort of ongoing desire for the code to always work. And there's also sometimes an ongoing desire for the code to always be updated to the most recent version. The two phrases for this are CI and CD. Let's see. I'm continuous integration and continuous development. And continuous integration is something that Kodi does all the time. The whole concept behind continuous integration is you want to make sure at the very minimum that Kodi, with the new upcoming PR someone submitted, that Kodi will compile with that PR, which means it'll actually come together into something that you can install. And once it's compiled, hopefully it'll run and it'll do certain key things. So let's go back to this. Let's go to this C GUI info manager and make sure it does what I want it to do. And hope it opens. There we go. So here we go. KSOOO has submitted this lovely PR, and it's gone through the whole process of everyone giving their input and saying what needs to be done. And then we get to this end point. And this point says, changes approved, all checks have passed. This branch has no conflicts with the base branch. What do those things mean? Those things mean this. We have something called Jenkins. Jenkins for Kodi generated this. Jenkins is a piece of software that takes a code base and compiles it and makes sure that it runs. And let me show you what that looks like. Oops. I want to make sure I go to the right Jenkins. Okay. So here is a copy of our version of Jenkins, jenkins.kodi.com, all running perfectly and doing its job. And as you can see over here, we have a build executor status, which means you're looking at all of the computers that we have sitting out there on servers whose only purpose is to compile either the main branch itself, which creates nightlies, or the main branch plus various pull requests, which creates test copies. So we see we have the master free and FreeBSD free, but our Linux VMs, They're busy building for Raspberry Pi, for ARM, and for Linux 64. Our Mac, our i7 Mac Mini, is busy compiling. Actually, do we have two? Well, anyway, they're busy compiling for iOS and for Mac OS. And then, of course, the Windows Skynet compiler, which is, of course, the computer designed to take over the world, is compiling for Windows and all the different varieties of Windows. Windows 64. Oh, it's not compiling for Windows 32 right now, but it is for Windows 64 and all of the exciting UWP versions of Windows. And you can actually see over here the Jenkins job list. And it shows all of the compiled jobs and the latest builds, and it tells you how they did. So let's see. Let's pick this one. So this compiled an hour and 7 minutes ago for Android ARM 64. And we can click right here, and it'll give us a little description of what happened. It was started by build multi-PR. So someone requested that this particular PR get built. It says this run spent 15 seconds waiting, 11 minutes building, and then so it basically took 11 minutes to build. The compiler left 9 warnings, and those are all detailed there, but no killer warnings. So it's basically a good build. And you can kind of see whether it's success or in progress by the green light. If there's a red light, that means the last build failed. And then once these builds have finished, a lot of times this is how we actually ultimately get that final release of Kodi. We'll take our final branched piece of Kodi for Kodi 18, let's say, or Kodi Alpha 1. We'll compile it through Jenkins. A lot of times Jenkins will go through the process of actually running a test. Yeah, here we go. Here's a test result. So it'll go through all these really quick tests to make sure that a lot of kind of the really simple things actually work. So it'll parse things, it'll make sure that the file system works, it'll make sure the CPU works, scrapers work, a bunch of the different helper file systems work, and it'll even go through the video info scanner, which means it'll actually semi-test to make sure that the build doesn't have any problems with video files. And if it passes with 0 failures, then we know we have a good build. And we have a build that users can actually use. And those builds will then go up onto the nightly build folder. Or if it is for a specific release, it'll go into that release folder. And that's how we use Jenkins. Back to the project. And that is... Oh, man. How long have I been going? I've been going a little while. That is... pretty much it. That's how the whole Kodi system works from start to finish. I realize I've probably stepped over some really important things, especially in GitHub, because there's just so much in it. But it's, in a lot of ways, it's a lot easier than you would think it is. It looks a lot scarier than it really is at the end of the day, especially if you've ever used any file system anywhere and hit copy and paste. So with that said, I'm going to sign off, but before I do, I will answer... Wow, there's only one question from Milton. I'll answer that question. I think this is on like a 30-second delay, so if anyone watching has any questions, feel free to ask them right away, or hold your peace until next week. So, Milton asks, when is Leia going to be released? Couldn't tell you, buddy. No idea. But an easy way to know, like I said, or an easy way to kind of guesstimate, and literally this is what we do a lot of the times, is go to pull requests, like I'm doing right here, go to milestones, and click open. And then first step is to go here on the left. Look for a Leia final milestone, and if you don't see it, look for whatever milestone of Leia that's currently open. Once all of these have been closed, whether they've been added or not. Sometimes they don't get added; they just get closed or they get pushed to the next milestone. But once all of the PRs that are submitted for that milestone are finished in some way or other, we'll move on to the next milestone. And so from this point, we're in the alpha milestone phase. We will then go to a beta 1. And in that phase, we'll have pretty different looking PRs, because all of the PRs, instead of being like these big sexy things like rendering, DirectX adding modern features and killing this huge global and removing MMLA rendering from the Raspberry Pi, all of those things will go away once we're in beta, and it'll exclusively be a series of PRs about fixing things that are broken. And then once that goes away, we'll go to beta 2. Users will submit their issue, will download beta 2, submit their issues, and we'll go through this process again. Usually once you get into beta, things start moving pretty fast. Ideally, sometimes it hasn't. I mean, I've been with the project for a long time, so there are times when it doesn't go fast. But ideally, it goes pretty fast. People submit their bugs almost immediately, and ideally they get fixed within a week or so, because usually the bugs aren't that big. They're just little stupid things that happen when you're writing for something that has 11,000 pull requests. And usually we'll go through like 1 to 4 beta releases until we have a release candidate. And then here's a sort of dirty secret of release candidates. In theory, the very first release candidate should not have any bugs, or it shouldn't have any like game-changing bugs. There might be a bug that doesn't matter, sort of, like it doesn't affect anybody, but it's not a game-changing bug. But what we'll do is every time we see enough bugs that we realize the release candidate's no good, we'll then go through the process of fixing things. But with the very last release candidate, a lot of times, if a week goes by and there are no bugs reported at all, we'll literally just rename the release candidate Release, because that's the sign that we're done. That was the final release candidate that didn't have any big bugs. So that's a little behind the scenes how we make the donuts. Sorry I couldn't help you on exactly when we'll get released. Your guess is as good as ours. That's just the process we go through. What's the latest news with RetroPlayer? I'll answer that. I'll answer that in a second. First, I'm going to get to Dark Fiber, because this one's kind of in the same area. How many alpha releases usually? Dark Fiber is tricky to answer that question, because we have sort of changed how we're doing alpha releases this time around. A couple of years ago, we would do an alpha release literally every month to encourage testing, because the code base was still kind of janky, because it just was. Now we haven't been doing that because the code base is pretty stable a lot of the time. Thanks mainly to CI, thanks to continuous integration. We know every time a PR is going to break things, and so we have a plan in place for what to do once that breakage happens. So we're going to do alpha releases pretty different this time around. In the past, it's been a lot. It's been upwards of like 8 or 12 or some crazy number. This time, my guess is we'll do probably 1 or 2, maybe 3. I don't know. I'm not in charge of that, but not very many. And then we'll be done. And then we'll go into beta. So back to Mike W. What's the latest news with RetroPlayer? Well, Mike, RetroPlayer is merged. RetroPlayer is now part of every alpha release and every nightly release of Kodi. I'm guessing the reason you're asking that, though, is because even if it's merged, a lot of the times that doesn't matter. Like, you can't use it the way you expect to use it because RetroPlayer requires binaries to actually play back content. And a lot of times binaries aren't included in our alpha releases. And I'm afraid, I'm sorry to say, I'm going to say something wrong here, because I know I know that we've gone back and forth on this, and I don't remember the last ruling we've had. But the situation is basically this. In most platforms, we really want to deliver retro player binaries using a repo, which means we need to have a repo system in place, particularly for Android, Windows, Mac, maybe iOS. Mac and iOS a lot of times are basically the same, so that sort of doesn't matter. But definitely Windows and Android and those big platforms. LibreElec will probably have their own repository. And that leaves Linux, which is just a bastard. It's just everywhere else is very simple. Everywhere else you compile it once and then it just works. But for whatever reason in Linux, that doesn't work. You have to compile it for, every version of Ubuntu or every version of whatever. Every version of Linux is going to need its own compile. And then each compile will probably need a 64-bit version or an ARM version or a whatever version. So to some extent, I think we're just sort of giving up on a lot of that and just hoping that the people who really need that support will get it through LibreElec. Wolfgang, who's in charge primarily of compiling for Linux, will have a better answer for that, frankly, and might have worked something out. But my understanding is Linux is sort of out for that kind of thing. But the rest of the platforms, we are currently working on trying to get some sort of system set in place. With Windows, it was easy and it's already done. I mean, it's already possible to be done. We have the code. We figured out how to do it. Same thing with Macs. My understanding is we have sort of figured out how to do it on Android, which has its own special permission system. And we're just kind of waiting to see if we will do that. I'm kind of in the dark on that. And in fact, probably the best thing to do is one of these weeks invite Garrett on to sort of talk about all these things. So maybe we'll do that so he can give a better and more concise, less winding answer than I gave. But so that's sort of the winding answer. Your options are to compile all those add-ons that let you play games and include them in Kodi, which is something we don't want to do, but maybe we'll do it anyway, but maybe we won't. Who knows? Let's see. I'm going to flip over. Probably don't need that screen anymore. I'll flip back if we need to. Yeah, Mike, I agree. I'd love to hear from Garrett on this too. He's there are some guys on Kodi's team who are really good at talking about whatever you want them to talk about. They've got a gift for gab, and Garrett is one of them. I'd love to have him on here and chat about it. But not next week. I think that's all the questions I've got. So let me prepare you guys for next week, and then we'll call it a day. So next week, the plan is to have Lucas, a.k.a. El Ruiz. I don't know. His name looked very Russian, but he's from Canada. We'll have Lucas on to talk about LibreElec and embedded systems, which sounds so boring. I promise it's not. It basically means he's going to talk about things like the Raspberry Pi and how to get Kodi on the cheapest, smallest, tiniest piece of hardware you can imagine. So we'll talk to Lucas next week. Thanks for watching, everybody. Sorry, it looks like we've hit 50 minutes. I know some of that was not really part of this video, but we've gone a ways. Thanks for watching, and I don't know. I'm excited to be back. I hope you guys enjoyed this, and I hope to see you again next week. Oh, and before I go, if you look up here, I have like 25 different links, and I'm starting a Patreon. Patreon is patreon.com/cordcutters. I don't expect anyone at all to donate to it, but if you want to, it's there, I guess. And I guess that's it. Thanks for watching, guys.